So welcome back. This is part 2 of lesson 5.3, slope-intercept form. So here's a question from yesterday. So remember, step 1 in writing an equation is to find the slope. So step 1 is to find the slope. Step 2, we need to find our b. So what we're going to do is we're going to pick a point. And then we're going to plug into y equals mx plus b. And then step 3, we're going to fill in the values. So let's try it. So first we want to find our slope. So 5 minus 3 over 2 minus 0. So that gives us 2 over 2, which is a slope of 1. Step 2, we need to find our b. So let's pick a point. We'll pick the easier point here. So we're plugging in for y equals mx plus b. So y equals mx plus b. So this is my x, this is my y. So y is 3 equals 1 times 0 plus b. So that's a 0. So I get 3 equals b. So then we have our m up here. And now we have our b. We solved for it. So now step 4 is to write our equation. So y equals 1x plus 3. Some of you at the start were probably saying, oh, there's that tricky one. Okay, that is our y-intercept, so it should be 3. So you could have skipped this step if you remembered that trick from yesterday. Otherwise, here's what we're looking at for today. So you should have your notes out from yesterday, your yellow gold sheet. So this method will save us a lot of time versus using a table. So what we want to do is mark our y-intercept first. So here's our slope is 2, our y-intercept is -3, so mark that -3. And then starting at the y-intercept, we're going to apply the slope. So our slope is 2, so that's really 2 over 1, or that's -2 over -1. Notice how both of those fractions reduce to 2. So I could go up 2, forward 1, up 2, forward 1, up 2, forward 1, or I could go down 2, back 1, down 2, back 1. So using either of those numbers, that's where I'm going to get my points from. Down, 2, back, down, 2, back. And then we want to connect our dots. Okay, and that will be aligned, so it should have some arrowheads on it. So draw a line to complete the dot. So rise over run, so that's why we want it as a fraction, so that you have those two numbers you can apply. So let's do this together. So we want to graph our b first. Let's find our b value. So number 1, I see a -4 for our b, and then over here I see a 0 for our b. So then we want to apply our slope. So this is a -3 over 2, or it's a 3 over -2. So if I do this top one, that's down, forward. So down, forward, down, forward. So 1, 2, 3, 1, 2. Or I could go with the second fraction, up 3, back 2, up 3, back 2. And again, we should be connecting our dots. So in number 2, our m value is a 1, so that's 1 over 1, or -1 over -1. So if I go with a positive, that's up 1, forward 1, up, forward, up, forward, up, forward, or down, back, down, back, down, back. And then go ahead and connect your dots. And you do need a minimum of 3 points on your graph, but always look at the positive and the negative. So this, just to double check, this would be going uphill, so positive slope. This is going downhill, so it should be negative slope, so we are good. Linear equations may be very useful to model real-life situations. So linear equations can be very useful to model real-life situations. So write this down. Slope-intercept form is y equals mx plus b. It is useful when the situation gives you a starting value b and a rate of change m. So x and y may be represented with other letters, like maybe a p or an m or an n or something like that. And the two variables, you'll always have to have an x and a y in there. So those two variables will always have to be. So this is the modeling part. So let's go back to our situation from yesterday. Adrian Peterson makes $2.4 million a year to play football. He also got a signing bonus of $500,000. Write an equation and make a graph. So what are the variables here? What's going to change are the years. So one of the variable is the year, and the other variable is his earnings. So what is a starting value? So $2.4 million is what he starts out with. Actually, is that what he starts out with, or is that what he adds every year he's there? I'm sorry. So this should be, he starts out with $500,000 just to sign the contract, and then he makes $2.4 million each year to play. So that's going to be our slope. So this is our b, and this is our m. So write your equation. So we have y equals 2.4 million times the number of years that he plays plus that signing bonus. So real world application, writing a linear equation. So year and earnings. And you could have used different letters here, M and N, if you wanted to. So here's that equation, and with the equation they have here, they left it in terms of millions. So, so then what I need to do is come up with a scale. So M is 2.4 and B is 0.5. And I think we'll save this one till I get back. Let's try another one. A plumber charges $65 fee for a repair plus $35 per hour. Write an equation to model the total cost of a repair that it takes for each hours. So we have to have an M and a B. So B is something that just happens once. So there's a $65 fee that happens once, and then it's $35 per hour. So this would be y equals 35x plus 65. So if we were to make a graph, here's our x-axis, here's our y-axis. The 65 is what's going to happen over here, and then when we're doing our slope, we would go up 35 over 1, up 35 over 1, and then we could draw our line. But we'll save the graphing for a later date. Okay, so here are 3 examples I want you to try, 1, 2, and 3. Check your answers with me when you're done. And because of time, we'll skip number 3. So number 1 should be 3x minus 4. Number 2 should be y equals negative x plus 1, and you could just have y equals negative x plus 1.